Hi, Algebra 2. Just wanted to take a look back on a couple of things that we had looked at today in section 3.1, which was graphs of linear systems. So you probably recall that we can solve a linear system three different ways. Back in Algebra 1, you learned how to solve by graphing, you learned how to solve using substitution, and you learned how to solve with elimination. And we started with graphing first because it was a very visual way of seeing what's going on. We have a solution to our system, all right? Recall a solution to an equation is the value of the variable that makes the equation true. A solution to a system is the value of all the variables that make all the equations in the system true at the same time, all right? And so the first way we learned how to do that was by graphing. So let's take a look at an example. We're given this practice problem, which was part of the CK12 set, 7x minus 2y equals -4 and y equals -5. Well, pretty obviously, we would solve this by substitution if we were given an option. But right now, we're practicing by graphing. And because we're doing distance learning, you could probably go ahead and try and graph this on paper. But one of the things about solving by graphing is you need to be really meticulous. You need to use actual graph paper, all right? If you're just kind of sketching one out on your own page, you may or may not get a graph that reflects the reality of the solution. And so, fortunately, we're in a place where we have technology available to us. So let's jump over to the Desmos graphing calculator. And we took a look at this in class. So we know that we can go ahead and enter, any equation here in the sidebar. So 7x minus 2y equals -4. And then y equals -5. So I'm going to go ahead and shift this on up. So here's our two lines graphed, and here's our point of intersection. Remember, if you hover over that and click in Desmos, it'll show you exactly what we have. So we have -2, -5. All right. And again, there's multiple ways we could have solved that that were much more efficient, that would not have required the use of technology or a graph. But because we're focusing on graphing today, this is what we did. So if we jump back over into CK12, I know that I have -2, -5. That's option B. I'm going to click that, and they're going to tell me, hey, nice job. It was a hard question. Okay. So keeping in mind that, when we get time to quiz or test over this unit, clearly I'm not going to ask you, hey, give me the solution to this system and then send you to Desmos and have you just graph it and have it just pop up. You'll be able to identify the solution, sure, but I'm not really sure that tells me a lot about you understanding how to graph a system to solve it. So we may ask in different ways. We'll take a look at one possible way from our other activity in class today that may show up on a test for you. Maybe something like, write a system of equations that has a solution of 1, -4. Or, what if we change this value? What would that do to the solution? And have you write about it a little bit. All right. So one of the other example problems that came up in CK12 today in your practice set was this one. And again, if I take a look right here, I know for sure I'm not going to graph these two. This has elimination written all over it. Okay. But we're in a place where we got asked to graph this. Okay. We've talked today in class, and you recall back from Algebra 1 that, part of the reason why, we don't graph all the time is there's some equations that just don't lend themselves very to be graphed very nicely. Let's take a look at what happens if we go and try and put both of these in slope-intercept form. Right? So I'm solving for y. Subtract 8x, subtract 8x. 14y equals -8x plus 4. Now this over here looks kind of nice. I'm like, hey, I recognize 8 is a multiple 4. Maybe this will turn out. But I'm dividing by 14. So y equals, and then I'm getting a fraction. I can reduce it. 8 and 14 are both even numbers. They divide by 2, so -4/7 x. And then 4 over 14 is 2/7. So this is the slope-intercept form of that equation. perfectly fine equation, but I don't think we want to try and graph this. Our intercept is kind of an ugly fraction. And so we're going to give our best guess as where that point might be, but that's the best it'll be as a best guess. And the same thing here. So I'm going to add 6x to both sides. So if negative 7y equals 6x minus 10, and I'm dividing again by negative 7. So negative 7 divided by negative 7 is 1y. Good. Negative 6/7 x, and then plus 10/7. So again, we don't want to graph either of these. Right? But using technology, our job gets slightly easier. So if we jump back over to the Desmos graphing calculator, clear these two rows, and let's type in 8x plus 14y equals 4, and negative 6x minus 7y equals negative 10. Oops. Got a little ahead of myself there. All right. So now we can see the point of intersection is the point 4, negative 2. And again, this would have been much easier to solve using elimination. I see 14 is a multiple of 7. So it would have been very easy just to multiply the second equation by 2, add them together, and I would eliminate my y variable. But again, we were spending time today talking about solving by graphing, and so here we are. All right, so that was our first practice segment during class today. And so we've talked about a couple of things. The idea of being able to solve a system of linear equations by trying to determine the solution, which is the value of the variables that makes all the equations true at the same time. And graphing is a very visual way to do that, as long as we're confident that we can be very meticulous about our graphs. So then later on in the class, we practiced in a Desmos activity. And this one was kind of interesting to me. So we were inside a Desmos activity, but we were not using the Desmos graphing calculator. We were using the sketch tool. Right? So it didn't go ahead and graph these automatically for you. I asked you to use what you know about slope-intercept form to be able to graph these two. And so we talked a little bit about back when you guys were in Algebra 1, and you first started learning how to graph a line, and your teacher gave you a table of values and some graph paper, and asked you to use the x inputs, negative 2, negative 1, 0, 1, and 2. So you repeatedly substituted those x inputs into your function, simplified, got a y value out. Now that's your ordered pair. So you have an x and a y. And then you repeated that 5 times. So now you have 5 ordered pairs, plotted those on the graph. If we were solving systems this way, because you remember what happened is about 2 weeks later, you all learned about slope-intercept form. You found out you only needed 1 point and a slope to be able to graph a line. You felt like, hey, teachers, what are you doing to us? Why'd you hold out on us this information? We had to do this long, tedious process, and now we know we just need a point and another point and we're good? Yes, but one of the things that had happened was, if you take a look at the example on the screen here, the equation we graphed in blue, y equals 2x minus 2. I'm sorry, the equation in blue is actually y equals 1/3 x plus 3. So the colors are flip-flopped here. When we're solving by graphing and you place 5 points, many times it's very, very easy to see the point of intersection. This point right here lived on the blue line, y equals 1/3 x plus 3, and it lived on the green line, y equals 2x minus 2. And so it was very simple to see that point belonged to both. And as part of the instructions, this student went ahead and drew a red arrow to show that was where the point of intersection, the solution, and then gave the ordered pair for it, which was 3, 4. So there was a big payoff with this Desmos activity in the sense that we were able to see visually what exactly is going on, is that we have one point that belongs to both lines. Remember, any point that's on a line, the x and y coordinates of that point are a solution to the equation. And so when I have two lines that intersect, they share that one point. There's one point that belongs to both lines. Well, that means the ordered pair, the x and the y, for that one point solve both equations. So now we can see visually how we're solving systems of equations using graphing.